So collimation is essentially, like in layman's terms, like the parallelism at which the light is coming from the LEDs or like the emitting surface. So if something is super collimated, it's going to have the light coming out in more straight rays versus if it's diffuse, it's coming out at all angles and things like that. And so when we use this in machine vision, we use it, we kind of use diffusion to make an area more uniform and kind of just blanket flat coverage, but we use collimation to essentially make edges sharper on a backlight if we're using it from a backlit perspective, or if we're using it from a front light coming down, it can highlight height changes better versus like a dome light, which is super diffuse, will hide those height changes. So it kind of works opposite in what a lot of the diffusers and dome lights and stuff that we expect does. But yeah, when we say like the degree of collimation, it's where you pick like a point on your sample and the angle at which the light hits that point is how collimated it is. So if it's got a high degree of collimation, it's big angle versus if it's more parallel, it's going to have a low degree of collimation.